Yeah. But, I mean, it's just kind of like what you'd guess if you just were like faced with it and just forced to make a guess, right? Like if I ask you what's the length of the matrix, a 2 by 2 matrix, 1, 2, 3, 4, what do you think the length of the matrix 1, 2, 3, 4 would be? Square root of what? Square root of 30? Because that's what you get from square root of 1 squared plus 2 squared plus 3 squared plus 4 squared? That's exactly right. So essentially, this Frobenius inner product just says you take your matrix and you write it out as a long vector with the components of the matrix, and that's the whole notion. And that is, in fact, what the Frobenius inner product is. Anyway, that's all I got to tell you guys about this stuff. Like, that's pretty much it. Let's look at the surprise attack missions together, yeah? And then I'll go print them for you guys if you want to hang around. If you don't, that's cool. I understand. Things to do, people to see, stuff like that. Let's see here. Well, okay, there we go. So this one, like problem 1 is just like what we were doing at the start of class, except instead of 2 vectors, I have 3, right? And like I wanted to make you guys normalize them. So I made that step 1, you guys have to normalize the vectors, okay? This is an important skill that you should acquire before the next test. I think it won't be an issue. You can divide by the length. All right. And then build the E1, the E2, the E3. These are 3 by 3 matrices that are basically built from the basis. And then, construct this, 6E1 plus 9E2 plus 12E3 and show that E1, E2, and E3 are eigenvectors. I actually want you to multiply the matrix, find out the matrix, and actually do the multiplication, see what happens, okay? Don't just assume it works like I showed you. All right, actually go through the calculation. But then for part C, I want you to build a matrix which has eigenvalues 6, 7, and 67. Okay. And I hope that it's somewhat clear how you would do that, given our discussion at the start of today. I don't want to, if I say much more, I'll solve the problem, so I don't want to do that. Part 2, problem 2 here, I'm like, look at the monomials 1x, x squared. It's a subset of the continuous functions on 0 to 1. And I say define the inner product here, integral from 0 to 1. That changes things a little bit, right? So you have to work through the same things we just worked through in class, but this time for the integral from 0 to 1. Okay? Yeah. And so like basically I'm saying do Gram-Schmidt and then normalize. And then down here, just like I was just showing you, find the projection of the exponential onto the span of that. So that would be, the inner product of 1 with v1 prime prime times v1 plus the inner product of, e to the x with the inner product of e to the x with v1 prime prime times v1 prime prime plus the inner product of e to the x with v2 prime prime times v2 prime prime plus the inner product of ex with v3 prime prime times v3 prime prime. The projection built from inner products with the orthonormal basis. So, yeah. I mean, there's a whole world of questions here that we could open up, but I won't. You could ask questions like, what's the perp? Is there a theory of orthogonal complements here? All of those questions have answers that are interesting, and we talk about those in Math 321, all right? Yeah. Let's see here, what was the other one? Did you guys already turn in 11? So there must be a 12, huh? Let's look at that one. Do you guys have any questions about it? I really should have posted this one like days ago. I'm sorry. I wrote this days ago and I just forgot to give it to you guys. My apologies. But most of you would have put it off right until before it was due anyway, so it's all the same, right? But it could have been due today. Rats. But so to find the QR decomposition, go back to what we did in class, right? You just need to orthonormalize the columns and use that to build the QR. Yep.
What is the comment about fuzzy edges?
Oh,
I was very confused.
right here. Can I have your,
Oh,
can I borrow that for a second?
yeah.
These are fuzzy edges.
It's the only one that I have to ask.
Yes. And so,
So we'll lose points if we do that.
what's the charge? Like half credit. I mean, I don't know. I don't know. I'm just asking. Let's see here. So you need to go back to the class that we talked about the rotations to understand this problem. The next one. You guys tell me what would the trace of that matrix be? Here it's important to remember we had that the trace of AB is the trace of BA, right? We proved this earlier, I think. Or I should put it on the final, I don't know. But so since that's true, the trace of beta transpose RB is the same as the trace of beta, R beta transpose. But beta times beta transpose is the identity, right? So the trace of the matrix is the same as the trace of this. But the trace of this is cosine plus 1. So if I say much more, I think I'll solve the problem. Yeah. Yeah. So, well, yeah. This one here, you write down the matrix, find the orthonormal eigenbasis, and then you can write down the eigenformula like we talked about. This one here, you just need to find the matrix, feed it into the website, right? And that website will tell you the eigenvalues, and you can just write down the eigenformula. That's all that. This one you must use technology, otherwise it would take an inordinate amount of time. All right? Any questions? You guys ready for the quiz? As a class? We'll know on Thursday? All right. Well, I hope so. I hope so. Yes, sir.
So going back to this, taking the integral over negative 1 to 1 or 0 to 1,
Yeah.
you get basically like things can be perpendicular or not perpendicular.
Right.
Based on what kind of integral you take. You use that to your advantage and then construct something that is perpendicular by changing the integral.
Well, I mean, like I said, the integral from -1 to 1 typically comes paired with like an application or something. Like there's a context in which these integrals arise. Like, if I can find it. Like in the particular context of the, there's a particular calculation where we change from theta to like the substitution variable, and it changes the integral from 0 to pi to -1 to 1. I can't find it at the moment, but anyway, like this is the formula for the potential as a sum of, these are Legendre polynomials, so like P0 is the 1 over root 2, and P1 is the x that we talked about, P2 is the thing we derived. I mean, that's like a general decomposition of the voltage in terms of a sum of multipoles. Pole, dipole, the quadrupole, the octupole. Anyway, I'm significantly digressing at the moment, so I'm going to stop. But like, yes, these inner products, they stem from problems in mathematical physics, which are born of particular differential equations typically, is probably the best answer to your question.